Hi, good morning. My name is Vaidya. I work in the DXE labs at Bangalore as the global CTO for National Grid account. In today's environment, the size and complexity of a data center requires a config management database CMDB more powerful than anything a traditional spreadsheet or a relational database can offer. A graph database like Neo4j offers powerful tool for storing, visualizing, and monitoring data center operations. In today's demo, let us see how to set up a Neo4j graph database with mock data and then visualize some of the data center operations. So we start off with modeling the data center. The endpoints like servers, routers, firewalls, racks of the data center can be visualized as nodes, and the connecting cables between them as relationships. Another type of node represents the network and interfaces. At another level, we have the OS, VMs, apps, and services that are modeled as entities. So without much ado, let us get into the demo of creating a mock data center and visualizing the operations. Let us start the Neo4j database at the local host. So it is saying starting Neo4j and will be available at port 7474. Let us quickly open that. Okay, so the instance has successfully started. This is a Cipher query language text file having a script to load test data into our database. So we go ahead and create a data center with the name DC1 and Reykjavik as the location in Iceland. We populate the database with 4 zones, and for each of the zone we ensure that it has its own separate network, IP address range, and the router. So we also go ahead and create 10 racks per zone, and then have specific machine types with auto created capacities for CPU, RAM, and disk with this CQL. So since we have 4 zones, 10 racks, we will introduce 200 machines of the types we introduced above. So in total we get 8,000 servers in our data center as test data. The next step is to ensure that there is test data for sample OSs and other application software. So here is some links to RHEL, Ubuntu, and Debian version history on the internet. We use them to populate the database. Finally, we create an index on the software and attach the software to ensure the database is complete in all respects. There is a tool called Lazy Web Cipher which can be used to load the script file and run it. Here I've uploaded the Cipher file from the local machine and then run it. So here is the output after the import has been done, and currently it shows as all done. So let us see how much data has been imported. Okay, so it is showing that approximately 30 MB of data has been created as test data in the database. Let us see what data model we have created so far. There's a built-in procedure called db.schema which will help us visualize the data model. So as you can see here, we have created the data center with a switch, egress router, various zones, machines with a particular type, and with particular OS versions and their other application software. We can visualize the network connectivity with this command. So this is showing the DC1 and the various routers and the interfaces. Entire data center up to 3 levels can be visualized with this. Let us now visualize the racks in the data center. So this is portraying the entire DC1 and the racks. Because there are 4 zones and each network zone has 10 racks, we have a total of 40. Let us try to find the details of one of the racks. Okay, so this particular rack has 146 machines, which are all interfaced with 147 interfaces. So this gives me a complete picture. Let us try to find the machine types. So these are the machine types available in the data center. Let us find out the OS installed in the data center along with their versions. So let us find out the other software installed. So this is the list of other software with their versions and their dependencies along with the ports. With a graph database, it is very easy to do dependency analysis. So let us do it for our data center. This is one of the visualization of a dependency analysis between machines, processes, the various application software, versions, and services. Again, with a graph database, we can do powerful configuration management activities. So, for example, let us check which all machines are out of date with the OS. So here it's listing the various machines with their rack name and the current version along with the latest version of the OS. So to conclude, a graph database offers a natural way of modeling, storing, querying, and visualizing data center operations. Compared to a relational database, a graph database is much more intuitive and easy to set up, as we have seen today. The number of use cases for which a graph database like Neo4j can be utilized for is really humongous. For example, configuration management, impact analysis, planning, networks security and hardening, IT governance like intrusion detection, analytics of user behavior, as well as traffic analytics. In our demo today, we have seen a small portion of how to use a Neo4j graph database for planning and configuration management of data center operations. Hope this was useful to you. Thank you for your time and have a good day. Bye.